else did I want? My resource sheet. And I was going to look for the success criteria if I had it. Where's the other side? All right. Not sure where it is. I can always pull it up on the computer. Okay. Here we go. So what I would like you guys to do is take out the example I did Monday, I want to say. So if you guys remember, we looked at the electrolytic cell, and we looked specifically at molten silver chloride. And what I was talking about is how do we process this question? So that was in the yellow coloring. You don't need to write those things down. I'm just showing you how to do something. And then the stuff in the red was the achieved requirements. So not a whole lot for the achieved. Just keep in mind, all you really need to do is first off, do the basic stuff that is going to be in every single question. So labeled cathode as your reduction reaction, labeled anode as your oxidation reaction. The other thing you need to do for the achieved is make sure you have your definitions down for what reduction means and what oxidation means. So you can either define it as the gain of electrons, or oxidation number decreases for reduction, and then for oxidation you can either write loss of electrons or increase of oxidation numbers. I just need a definition. The last generic thing you need to write down for all electrolytic cells is that this is a non-spontaneous reaction, or you could write down that it requires energy. Either or, that's enough for the achieved. And the last thing, which is the trickiest, is actually decoding the example that I give you. So taking your ionic compound, splitting it into its two ions, whichever is the cation is going to get reduced, because we see a positively charged ion. We need to add electrons to make it lose that positive charge and thus go to the element. And then for the oxidation, you're looking for the anion. Makes sense, anion, anode, they all kind of pair together. And we're looking at taking away those electrons so then it becomes zero charge, no charge to it. So loss of electrons. Keep in mind that when you're trying to figure out your products, again, that's an achieved requirement, you are using your resource sheet to find the pair. One should be going in the forward direction, and that one shows your reduction. If you're not sure if forward or backwards is reduction, this is called standard reduction potential. That's your hint that that's reduction going forward. And then going in reverse is oxidation. You should always have one of each. The other way to idiot check yourself is to make sure you are going from ions to elements in this one. Are we good so far? All right. So let me show you guys the merit level requirements. We're going to do a little bit of revision for some of the oxidation numbers and the, what do I want to call it, equations. And then we will have some study time. All right, so I will put the merit level answers in blue. And I'm running out of space of where to write. So we're going to write... All right, M equals blue, so we know that that's what we're going to have to add on if we want to increase our achieved level answer to a merit level answer. Now, one of the first things that I'm going to be looking for merit is, are you justifying your answers with more detail? So more detail is going to be oxidation numbers, it's going to be specific electron numbers, and it's going to be equations. So in this case, it's really simple oxidation numbers because we are just looking at ions and elements. We don't have to worry about doing any oxidation math, which we talked about last year. And in fact, all the examples that I'm giving you for both the galvanic and the electrolytic are just going to be simple ones as well. So when it comes to the merit, what I am looking for is, first off, you are talking about the change in oxidation numbers. So we're looking, in this case, my chloride, we see its charge, and its oxidation number initially is -1. Then I'm going to the element. So the oxidation number now is what? 0. So if I want to add some more details, this has increased oxidation number by how many? 1. By 1 from -1 to 0. All right, what about my silver? What's its original oxidation number? +1, because it's just, again, we're using the charge of the ion, so that's +1. What's the next one for the element? 0. So in this case, the oxidation number has decreased by how many? By 1, and we're going from +1 to 0. So that's the first level or layer to my next justification. Keep going. All right, now what I'm going to use is that information to figure out my electron numbers and how they got transferred. So remember, electrons are negatively charged. So if I am increasing my oxidation numbers by 1, I have lost 1 electron. So in fact, I can specify this and actually take away that S because I know it's only just 1 electron. In this case, my oxidation number is decreased by 1, so I've gained 1 electron. I personally like to go oxidation numbers first and then electron gain or loss because they're going to match. The other thing to be mindful for the merit is now you need to have both of this information. You can't just have one half of the story. You need both the change in electron number and the change in oxidation number. So this is now an and for the merit instead of an or. It's an or for an achieve, it's an and for the merit. Are we good so far? All right. All right. The other thing I need to do now for the merit is I need to do my equations and I need to balance them. So silver is really easy because I see that I have a +1 on this side. Sorry, let me backtrack. I have a 1 silver on this side and a 1 silver on that side. So that's already balanced. The next thing I do after I balance the element is I need to balance the electrons. So I see here that this is a +1 charge. This is a 0. So I'm adding 1 electron to this side so that way when they come together, I get no charge on the other side. So I'm just going to squeeze my electron in there because I didn't put it very well. But I'm showing my equation. So you should have your equations for the merit. Hopefully this is ringing a bell from last year. The good news is the level 3 equations and things like that are far easier than level 2s because I'm just going to give you like ions. So it's less confusion. All right, on this side, I see I have 1 chloride and then chlorine. I see there's a 2 underneath it. So that tells me I have 2 chlorine atoms, but only 1 chloride atom. So I need to balance that. And the way I balance that is by adding a 2 in front. Now, we're going to have to do a little bit of math here. So we see how I have -1 as my charge, and I have 2 of them. So -2 is the charge on my left-hand side. I need my right-hand side to match it. And we match it by adding our electrons. So in this case, we are adding the 2 electrons, which makes sense. It's oxidation. It's releasing them. So we should always double-check that our electrons are on opposite sides when we compare these 2 equations. It's a good way to idiot check yourself. Do I have my equations on the opposite sides? If they're on the same side, something's going wrong. Now some of you guys might be wondering, why did I write lost 1 electron when there's 2 electrons in the equation? The reason why is because there's 2 chlorides. So be mindful, whenever we're talking about oxidation numbers and electron numbers, we're referring to 1 atom. Not the total, but the total needs to be shown in the equation. So for the merit, you need to have the half equations. Okay? Last thing for the merit is you need to identify what is going on observation-wise. So it says there's a pale green gas. We need to figure out what that pale green gas is. So now, instead of just having that as, something we're using for processing, now we need to say what it is. So there are bubbles, and these are pale green. So I'm looking at my products, and I'm thinking, what product am I having that is resulting in that pale green? So that's, again, where the resource sheet comes in handy. I know that chlorine was one of my products, and I know that copper was another one of my products. I can see here that the chlorine gas, that matches the state and it matches the color. So when I'm labeling it, these bubbles that are pale green, that is the chlorine that's being formed. The solid is a like pink brown. I'm gonna write actually deposit 2 on there. And again, we use our resource sheet, and our resource sheet tells us that that pink brown metallic luster, that's my copper. I'm not writing the 2+ ion because that's talking about the ion. Sorry, the copper 2+. If I wanted to write down a third observation, I could write down that I noticed that the solution's becoming less blue because we're losing that copper ion. But I'm not gonna be terribly fussed on that one. Are we okay so far? All right, what questions do you have? Are we good? All right, there's one more thing you need to do for merit, and that's calculating your E cell value. So I'll talk about what that is. So the E cell is talking about these standard reduction potentials. So what I need to know is how much energy is required for this reaction to occur. If I don't have enough voltage, the reaction will not occur. So that's how we're thinking about the standard reduction potential. And we have all of our redox pairs here. What you're gonna do is you're gonna look for your reduction pair, the number that it provides, and you are subtracting the oxidation number. So when I look at my list over here, I am first going to be looking for my reduction, which is my copper, which is right here, which is 0.34, and then I'm subtracting away the standard reduction potential for my oxidation reaction, which is this guy right here. So that's minus 1.36. Are we okay with how I got those two numbers? Men, are we okay? So it's subtraction, but because I'm subtracting a positive number. So if I'm minusing a positive number, it's still subtraction. If I'm minusing a negative number, then it's an addition reaction because it's two negatives. Okay? All right. Now, I can't do mental math, so I'm getting a calculator. You are allowed a calculator on this assessment. Also, it's a good way to not make a silly mistake. So I'm taking 0.34 and subtracting 1.36. And my answer is negative 1.02, and volts is the unit that we're looking at. So that's the next thing I'm looking for the merit, is that you've done that calculation. And that's all you got to do for the merit. You're done. Not too bad, eh? And then you guys are going to laugh at the excellence, because the excellence, like always, is a really easy step. It's the big step is achieved to merit. The small step is merit to excellence. So you might as well give the excellence a go. If you don't get it, then you still get a merit. Right. Last bit? Okay. Sure. So if it's in green, that is the excellence that we need to add on. All right. One of the things I need for excellence that we don't have right now is my full equation. So I have my two half equations here. So here's a half, and that one's my other half. I need to put them together in order to get my excellence. So if you guys remember from last year, we need to make those electron numbers match in order to combine that equation together so the electrons cancel out. This is 2, this is only 1. So what I need to do to get those equations to come together is I need to multiply this whole equation by 2. All right, I'll backtrack. This equation has 2 electrons. This equation only has 1. I need those electron numbers to match, so I'm multiplying this whole equation by 2. So when I multiply that equation by 2, I would have 2 electrons plus 2 Ag plus arrow 2 Ag. That's what the multiplication by 2 is. Arrow, sorry. I messed that up. With this side, I don't need to do that because you see how it's already 2? So I want the reactant and product side to match. What I'll do is I'll write the equations next to each other, and I'll show you how I put them together so you can see what I mean. So unfortunately, I'm running out of space. Do you guys want me just to move on to a new piece of paper or keep jotting things down here? Yeah. Yeah. I'll finish this and then I'll go back to the E-cell. Because I need to talk about the E-cell anyway. Do you guys want me to put this on a new piece of paper or should I just keep jotting it on the one? New piece of paper? Okay. So I'm just mindful that it's looking a little bit messy right now and it's messy. All right. So with these 2 equations, I like to line them up so that way my arrows are in the same spot so I can easily see how things are going to cancel out. I'll copy this equation down. That's one of my half equations. So 2Cl minus, and I think that's it on that side. And then on the product side, it's Cl2 and 2 electrons. For my silver, I have 2 electrons plus 2 silver ions, and then my product is 2 silver as the element. So I've lined up my 2 equations. So these are your half equations, and that's what you need for the merit. All right, so now that I've lined up my equations, we're gonna play the canceling game. Now, if you guys remember last year, it was a lot more complicated because you had water and things like that. This year, really easy because I'm not gonna do any complicated equations. So I have electrons on this side, I have electrons on this side. I see that's 2, I see that's 2. That's good, they cancel out. Now I can just put everybody together. So 2Cl minus plus 2Ag plus makes Cl2 plus 2Ag. I told you, the equations this year are easier because I'm not giving you the complex ones. There's no bonus points to doing that. So that's your full equation. You're going to need that for excellence. All right, keep going. So that's one thing you need for the excellence. The second thing you need for excellence, and I'll explain the E-cell again. Yeah, because I was asked to explain the E-cell again. All right, for the E-cell, The calculation is, we want to look at these numbers here called the standard reduction potential. All of these reactions are basically looking at the half equation and the energy, and we look at them in reference to hydrogen as our zero. So based off its reaction with hydrogen, it's either going to oxidize or reduce, blah, 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 blah. You don't need to be able to explain that. All you need to be mindful of is all these numbers here are useful to us. So we can look at the number we get for the reduction reaction and look at what we get for the oxidation reaction, and we can subtract them, and then we can calculate the voltage. So when I'm looking at this reduction reaction here, I've taken it from my, did I grab the wrong number? I totally grabbed the wrong number. I forgot we were dealing with silver and not, sorry, we don't want copper. That's my mistake. No wonder why you guys are confused. We want silver, which is hopefully on the list. It's right here. Sorry about that. It's just a small change. That number changes to 0.80. That was my mistake. Don't make that mistake. That's an easy way to go from merit to an achieved. Good way to go from merit to an achieved. And unfortunately, we don't allow resubmissions for merit. All right. That makes more sense. All right. It's still negative, but it's now 0.56. My bad. Sorry about that. Anyway, I've looked for my reduction reaction, which was the silver. So that 0.8. And then I looked for my oxidation reaction, which is the chlorine, and that's 1.36. So that's where I pulled those two numbers from, and then I'm just doing a subtraction. What this number tells me is how much energy I need to put in to get this reaction to occur. So if I don't have 0.56 volts of energy, I won't get this electrolysis occurring. What's important for you guys in order to get to the excellence is recognizing that this is a negative number. So since it is a negative number, that tells us this reaction is non-spontaneous. You will always get a negative number for electrolytic cells. If you are getting a positive number, you probably just have the numbers the wrong way around. It's a very good hint. So, since the E cell is negative, this is a non-spontaneous reaction. And requires energy. So basically, we're taking what that achieved sentence is, and now we're actually justifying it, which is the difference between the achieved and excellence. Or actually, achieved merit and excellence, I should say. An achieved level student just regurgitates that information. Electrolysis is non-spontaneous. A merit level student shows me the math behind it, and an excellence level student takes the math they've done, takes that statement, and ties it together. And that's all you got to do for the excellence for this electrolytic cell. So it's not hopefully too bad. So just FYI for this assessment, there's 3 potential components. First potential component, which is what we'll do on Monday, is the electrolytic cell. Second component is the galvanic cell. And then if you want excellence, there's a compare and contrast that you have to write. If you're not aiming for excellence and you just want a merit or an achieved, you don't need to write the compare and contrast. That's basically it. You may. Question. What do you want? We're missing something. We can't see something. I know it's a lot of stuff.
Is that C or NG?
Oh, thank you. Oh my goodness. Yes, I was just having such a massive brain fart and I totally got the observations wrong too. Sorry. You guys, you need to catch me. All right, the solid deposit is gray and is silver. My bad. I was totally in the world of copper for some reason. I don't know why. Don't do that. That would also get you marked down to an achieved. I know. Well, yeah, I'm just an achieved level student, I guess. This is a good example of not rushing your work. Excellence level students, don't rush. Thank you. I'm so sorry, guys. I'm so used to using copper as my example. I know, I'm so sorry. I am recording it. I will scan this, put it online. I don't think I want to do another example right now because I think it'd be good for you guys just to practice a little bit. If we feel like we need another example, I can do one later in the lesson, or I can do one tomorrow. All right? Questions, concerns, comments?
Is there anything else that's low?
Is there anything else that's wrong? No, I don't think so. I think that was it. All right, cool. I'll stop the recording here.